today we are going to study first even function and odd function, then nature of graphs of x square, x cube, x raised to 4 and x raised to 5. Then the multiplicity of roots and how to use synthetic division to find the multiplicity of roots. And in the last part we will see some important question for our exam. So let's start with the even function. So consider a function f of x where x is a real number. Then this function would be called as an even function if we substitute minus x in place of x and get it equal to f of x. Examples of this function even function are x square, x raised to 4, so on up to x raised to 2n. So this is our graph of x square. So now let's take x equal to 2. So our f of x would be equal to 4. Now we will take x equal to minus 2 and that would also give us 4. So our criteria for even function is satisfied. Now let's study the graph of the function x cube. So let's take x equal to 3 here, and then our value of our function will be equal to 3 into 3 into 3, which is 27. Now we put x equal to minus 3. Then our function's value would be minus 27. So here what we get is f of x f of 3 is equal to negation of f of minus 3. And this is our criteria for our odd function. So for odd function, f of x is equal to minus f of x. So we need to remember that in an even function, f of x is equal to f of minus x, and in odd function, f of x is equal to minus of f of minus x. Now we are going to study the nature of graphs of x square, minus x square, x cube and minus x cube. First we define what do we mean by leading coefficient. So the leading coefficient is a number written in the front of the variable with the largest exponent. So for our first graph equation, we have 1 as our leading coefficient. because the largest power of x is 2 here and nothing is written in the front of it, which means it is 1. And in the second graph we have leading coefficient as -1. In the third one we have leading coefficient same as the first graph, which is 1, and here it is -1. Now we see the nature of these graphs. So in x square we can see that both the ends are up, and in minus x square we have both the ends downwards. So we can write the relation between leading coefficient, degree of the equation of graph, and the nature of graph. So from here what we can conclude is, in the first graph we have leading coefficient, which is represented by an to be greater than 0, which is 1, and the degree of the equation is even, which is 2. And from the graph we can see that its nature is that both the ends are up. In the second graph we have the leading coefficient less than 0, which is -1. Degree of the graph is even, and we have both ends downwards. And the third graph we have our leading coefficient as 1, which is greater than 0. Degree of the equation of graph is odd, which is 3, and the nature of graph is that the left end, which is this, is downwards. So we write left end down, and we have right end upwards. In the third graph our leading coefficient is -1, which is less than 0. Degree is odd, and the left hand of the graph is upward. So and the right end down. So from here what we can conclude that whenever the leading coefficient is greater than 0 and the degree of the graph is even, then both the ends of the graph would be upwards. So let's take another function. Let's say 2x square. So we can clearly see here that both the ends of the graph are upwards. Now we take -3x square. So as we can see that both the ends of this graph, which is -3x square, is downward. So we have drawn some simple graph x square, x cube and -x cube, and drawn a conclusion about the nature of the graphs for all such even and odd degree function. So now let's start with our next topic, which is roots and multiplicity of roots. So what do we mean by roots is that we have a function, let's say f of x. The value of the function f of x becomes 0 at let's say some real number x. So we call this real number as our root of the function. And now we will see what is multiplicity of the roots. Multiplicity of roots is the number of occurrence of that root in the complete factorization of the polynomial. So let's take a function which is f of x equal to x square minus 1. So we know that its roots would be minus 1 and 1. Now we have to factorize this equation, which would be x minus 1 and x plus 1. So we can see that here that minus 1 and 1 each occur only one time in our factorized polynomial. So the multiplicity of minus 1 is 1 and 1 is also 1. Now let's take another function, minus x cube minus 4x square plus x plus 4, and roots of this function are minus 1, 1 and minus 4. To find the roots of any function, you should randomly put values of x so that we get the function's value as 0. So now we will factorize this equation by synthetic division. Hope you know that how to do it. So let's take our root 1, and in this column we will write the coefficients of our equation. So x cube ka coefficient is minus 1, x square ka is minus 4, x has the coefficient 1 and the constant term is 4. Now we would simply write here minus 1, multiply 1 with minus 1 and write their product here, and afterwards we add minus 4 and minus 5, which is minus 1, which is minus 5. Again multiply minus 5 with 1 and write their product in this column. Add 1 and minus 5, which would be minus 4. Again multiply minus 4 with 1, we get minus 4, and adding 4 plus minus 4 we get 0. One thing to remember that is if we get this the number here as 0, then only we can say that the number which we took here, which is 1, is the root of our function. Now we will see how we write the factorized polynomial here. So we just put x here and number which is 1 here, we just negate it and write like this, and numbers here should be written as, this is our constant term, this is the coefficient of x term, and this is the coefficient of x square. So we write this polynomial in the second bracket. So we get minus x square minus 5x minus 4. So we have factorized this polynomial such as x minus 1 into minus x square minus 5x minus 4. Now again we would factorize this polynomial, which is minus x square minus 5x minus 4. So we write the coefficients, which is minus 1, minus 5 and minus 4. Now we can see that here in the place of x, if we put minus 1, we would get the polynomial as 0. Let's see, minus 1 square minus 5 into minus 1 and minus 4, which is equal to minus 1 plus 5 minus 4, which is equal to 0. So we write the number minus 1 here, carry down minus 1, multiply minus 1 with minus 1 and we get 1, add minus 5 to 1 and we get minus 4, multiply minus 1 and minus 4, we get 4 and we get the last number as 0, which means that minus 1 is the root of our function. So how do we write the factorized polynomial of minus x square minus 5x minus 4? So as we have seen earlier, we just negate this number here and write it as x plus 1, and then our second polynomial in the second bracket would be, this would be our constant term and this number is our coefficient of x. So it is written as minus x and minus 4. So our first polynomial, which is this minus x cube minus 4x square plus x plus 4, is factorized as minus 1, x minus 1, and this polynomial can be written as x plus 1 bracket x plus 4 into minus 1. Here I have just taken out minus 1 and written it separately. So from here we have found out all the roots of the function, which is